Problem 28. Label each diagram as a strong electrolyte, weak electrolyte, or non-electrolyte. And we have two diagrams here. So what are these particles that are dissolved in the water? Those are water molecules in the background. And what are those particles? That's going to tell us whether it conducts electricity well, strong electrolyte. If it conducts electricity a little bit, weak electrolyte, or it doesn't conduct electricity at all. Now, you should know the colors of all of these atoms, but I'll remind you right here. These are the four big ones, so memorize those. Looking at the two diagrams, if you look carefully, you can spot four different types of particles. Okay, the first one has a blue, a black, and a white one, so that's going to be HCN. HCN. This is called hydrogen cyanide. It's a covalent compound, and covalent compounds are made of molecules. This substance right here is actually what's called a weak acid. Now, we haven't learned acids yet in our course. We're going to see them more in Chapter 9, but what weak acids do is when this stuff dissolves in water, a small percentage of the molecules ionize. They split apart into H pluses and Cn minuses. These are called protons, and those are called cyanides. So weak acids do this, and if you look carefully over here in diagram A, you can see right here. Here is one of these carbon nitrogens. That's a Cn minus. That's called a cyanide ion. And this is a polyatomic ion. We learned about polyatomic ions back in Chapter 3, and you should, if you need to, go back and look at that chapter. You should see the cyanide ion. Now, there's not many cyanides in here. There's only one. And in weak acids, when they dissolve in water, they only ionize a little bit. So for every 100 of these molecules, you might get one cyanide and one corresponding proton. Now, when you got protons, H pluses in water, they always associate with a nearby water molecule. And so rather than seeing a little hydrogen atom by itself, what happens is it latches onto a water molecule to form what's called a hydronium ion. So if you have some of your HCN, hydrogen cyanide, splitting apart into cyanide ions and protons, those protons come in the form of what are called hydronium ions. And you can see one of these. So you got that one cyanide and the corresponding hydronium ion. Now, solution A only has a couple of ions in there. So most of what's dissolved are molecules. There's only a few ions. That's going to make solution A a weak electrolyte. When you just have a few ions, it's not going to conduct electricity very well. It does so a little bit, but not very well. So this is a weak electrolyte. So what about B? In B, if you look carefully, you'll see that this is what the molecules are. You have carbon connected to 3 hydrogens, and then connected to an oxygen, and then another hydrogen. So this is CH3OH. This is a substance called methanol. It's an alcohol, and it's a covalent compound, and it's made of molecules. Now, this is not a weak acid like hydrogen cyanide, so none of this guy splits apart. So you won't see anything else but the methanol molecules in there. And so in diagram B, all you see are molecules only, no ions. That's going to make diagram B, or solution B, a non-electrolyte.